Our Energy and Sustainability Research Group takes a whole system approach to a sustainable net zero energy transformation. So we deliver efficient solutions for the supply, conversion, distribution, and storage of energy. Part of the energy transition that we aim to support is really that shift away from the conventional fossil fuels and the conventional way of using such fossil fuels, and in parallel, the development of new clean energy carriers. And so among the alternative, unconventional, renewable energy solutions that we are working on in our team, I can certainly mention geothermal energy, bioenergy, heat pumps, and also the recycling of waste. So turning that waste into itself a renewable energy form. But even though we are working in engineering, we can never lose sight of the sustainability and ethical aspects of the solutions that we develop. And this is the reason why we really strive to also make an impact, a positive impact on our own communities. And we do that by supporting, for example, the development of equitable and sustainable energy interventions at community scale. For example, if you take the city of Glasgow, there are opportunities where you can create off-grid renewable energy and use the energy for things such as community greenhouses, or also a water source heat pump that can feed into a block of flats without being connected directly to the main grid. We work towards the development of technology that ultimately gets used. And so examples of these are our development of heat pumps.
At the moment, the government strategy for decarbonization for net zero is to install 19 million heat pumps by 2050 to decarbonize the heating sector, particularly the domestic heat sector. And the current heat pump technologies, they have their limitations and drawbacks, and they have areas can be improved. So this is why our technology can help in that area to improve the energy efficiency of our heat pump technologies. The basic principle is pretty much similar to the fridge or freezer in our kitchen, but we designed it in an innovative way to allow it to draw heat from river water, from soil, and from air, and then we reject and produce heat to our central heating system or to the air in our house and our building. So in this way, we consume 1 unit of electricity. It can provide 3 or 4 units of heat. And so the energy efficiency is much better, and then we just directly use electricity, use a resistive heater to produce heat. You consume 1 unit of electricity, you can only produce 1 unit of heat.
Our goal as energy team, and I would say probably as University of Glasgow as a whole, is to be able to carry out our research in a framework that embeds us fully in the landscape of the stakeholders, the ultimate stakeholders. We are not here to do independent research because it is nice to do so, because of course we find it interesting and challenging, but we want to really be part of the problems definition and be there since day one in helping the stakeholders solve these problems.